Hello, everyone, and welcome to HashiConf 2015. We're so excited to have you here today. Before we get started, I have a few housekeeping notes. First, if you have not already connected to the Wi-Fi, the information is on the screen behind me. The SSID is HashiConf, and the password is automation. Speaking of devices, please take a moment to make sure your laptops, tablets, e-readers, Apple Watches, Android devices are all on silent mode. This is a no-smoking facility. Additionally, there's no open food or beverage allowed in the theater. However, you are allowed to have closed containers and drinks with lids. If you have any questions, please confer with the conference staff who will be outside of the doors, but you're more than welcome to eat lunch and have breaks inside the main theater. Speaking of trash, please keep up and clean up after yourself. There are trash receptacles all throughout the facility. Please do not leave any trash in the main theater. Speaking of food, please only take the food you need. We've worked with a local Portland charity, the Blanchett House, and any leftover food will be donated to that charity. You can always go up for seconds, but please only take what you need because once it leaves the buffet table, we can no longer donate it. I wanted to take a moment to talk about Slack. We received a number of requests to create a Slack channel for HashiConf. At HashiCorp, we're building tools that automate the modern data center, but we've never talked publicly about one of the motivations for building those tools. We build tools that automate technology and process so that you can spend time doing the more important things in life, like spending time with your friends, family, and loved ones. And we want HashiConf to embody that spirit. So we're encouraging a new kind of communication first at HashiConf. And it's one that involves face-to-face interaction. It's called genuine human connection. And it works like this. At the HashiConf booth on the second floor mezzanine, you'll find a number of product stickers. I see some on laptops and badges. That's great. What we're asking you to do is take those product stickers that you're interested in. Maybe you're a user, maybe you're just following, maybe you have no idea what it is, and you want to talk about it. Put that sticker somewhere on your badge, on your shirt, on your lanyard, and that's an indication that you want to talk about that product. Now, find other people who are wearing that same badge and start a conversation. This is genuine human connection. And if you do have something that you want to share with the outside world, please use the official conference hashtag HashiConf for Twitter and social media. I want to take a moment to invite all of you to review the code of conduct posted on the conference website. The code of conduct details what actions are and are not permitted at a HashiConf venue, and this includes not only the theater, but our post-conference event, the evening social at Plaza del Toro this evening. We've recently updated that website to include a toll-free number. This toll-free number is available for anyone with a US cell phone. It receives both phone calls and text messages, and it's anonymized. So if you do want us to get back to you, please leave your name and number in the event of a conduct violation. This number will go direct to a conference chair or to a secure voicemail in the event that a conference chair is unavailable. Additionally, you can find anybody wearing a blue HashiConf shirt. It'll have the HashiCorp logo in the upper left-hand corner. They'll either be able to assist you or get you in direct contact with a conference chair. Those are all the housekeeping notes I have today. I'm super excited to welcome founder and CEO of HashiCorp, Mitchell Hashimoto, for this morning's opening keynote.
Thank you. Thank you. We have some really, really exciting things for you today. So welcome to HashiConf, our first HashiConf ever. Around you, you're surrounded by over 300 of our most passionate community, most loyal customers, and some of our most devoted partners as well. You'll get a chance over the next 2 days to meet, learn from these people, and also you'll get a chance to talk with the 30 or so HashiCorp employees that work on these tools every single day. Over 10 of the core committers to our projects are also here as well, so you could find them. You know, It was about 3 years ago, almost to the day, that Armon and I started HashiCorp. And we've never had a chance to talk about how far we've come in those 3 years. In 2012, when we started HashiCorp, the only software we had was Vagrant. It was very successful, it had millions of users, but it was only the starting point. Armon and I knew we wanted to do so much more than that. In fact, a lot of analysts even categorized us as an IDE company at this point in time, which today is kind of funny to think about. But in just 3 short years, we've come quite a long way, and we have 6 products today, 6 open source products and 1 incredible commercial product. In the middle, we have the one that started it all, Vagrant, a tool for building development environments, distributing them, getting up and running very easily. To its right was the second product we came out with, Packer. Packer is a tool for building machine images, building containers, and other deployable application artifacts. Going to the left in the red circle, we have Surf, a cluster management tool that's used by some incredibly large clusters of over 100,000 machines in a single data center. Above it in the purple circle, we have Consul, a service discovery, monitoring, orchestration tool. This is used by some of the biggest websites in the world. To its right, in the lighter purple, is Terraform. You could describe entire data centers in code, bring them up with no human interaction in just minutes. We're talking thousands and thousands of machines all happening automatically. And then the most recent member of the family in the black circle to the right has been Vault. Vault's a tool for storing secrets, passwords, certificates, logging access to machines, all that sort of stuff. Vault's a single solution for all your security secret management needs. And then the bottom middle, we have Atlas. Atlas is our commercial product that brings all of these together and gives you a consistent workflow all the way through. So we've been very busy building these things, and I think everyone knew that we started from Vagrant, from a strong foundation that was very successful, but we've never had a chance to really show you how much is happening with all these other things. Well, I'm happy to show you they're all doing pretty well. We started tracking downloads only in 2014, but you could see in the first quarter of 2014, we're just getting just over 600,000 new downloads per quarter. And in about 18 months since then, in the most recent quarter, third quarter 2015, we got over 6 million downloads in a single quarter. So this growth is really phenomenal. So you can see this was cumulative downloads, but I also want to break this down and show you product by product how this is doing. Let's look at Vagrant. Looks good. Packer, very similar curve. Consul, doing pretty well. Terraform. And then most recently Vault, which has only been out for a couple quarters, but is actually the fastest growing product yet. And this is from our data, but you don't need to take our word for it. This week, RedMonk, an analyst firm that we're not customers of, we do not pay, published this publicly. Here's a look at HashiCorp since 2010 in terms of star count of our projects, which is a rough measure of popularity. And if we remove Vagrant from that point, you can see the rest are doing pretty well, and it gets a little bit ridiculous with Vault over there with a vertical line straight up. And they have this to say about it. It's quite easy to dismiss growing likes of distinct products to a company having the same set of fans. But this is not the case for HashiCorp. Only 1% of users have starred every single product. And this is important because we've built products across 4 very distinct categories: development tools, operator tools, production and runtime tools, and security. They're very different people, they're very different organizations, and we've been successful in every single one. And not just successful, but market leading. Behind the success, we have we have amazing customers. We talked with 3 to work on case studies, and I want to talk about them briefly today. Mozilla, Condé Nast, and ClassPass, 3 companies with very different goals, 3 companies at very different stages. Mozilla, I think everyone in this room knows, creators of Firefox. They've been using all of our tools, including Atlas, to help transition from private data centers to a public cloud. Condé Nast, one of the world's largest media companies, has been doing the same, has been using all our tools in Atlas, this time to help build out a brand new global business unit that has to function globally. ClassPass, one of the world's fastest growing startups, has been using us to keep up with that growth. And in addition to these 3 customers that we work very closely with, we're talking to many other categories of companies every single day. I've listed some diverse major categories of people that we're talking to that are using HashiCorp tools today. Government agencies, not just the US, but other governments overseas as well. Our tools are a big part of the 2012 Obama campaign, and we're already working with more than a handful of presidential candidates and campaigns for 2016 as well. Healthcare, a very regulated, difficult industry to enter. Gaming, massively multiplayer online games. We make sure the servers are scalable, monitored, keep running, etc. Financial institutions. If you've spent money in the past few days or traded stock, you've inadvertently interacted with a HashiCorp tool. Retail and e-commerce, so even brick and mortar stores. Some of the biggest brick and mortar stores in the world use HashiCorp tools, not just for e-commerce, not just for their websites, but for the software that manages their registers, inventory management, and so on. And there's many, many more categories, but I just wanted to list some of the noteworthy ones here to say that HashiCorp tools have a broad impact across many different industries. In addition to our customers, we just this week announced a new partner program. We have technology partners and system integration partners. The tech partners on the left are big companies we're working with to ensure our tools remain compatible with their ecosystem. Representatives from many of these companies are here today. And to the right, we have system integration partners. System integrators are generally consultancies that we have trust, they have a strong understanding of our entire tool set. We've tried to partner with system integrators all around the world to ensure that everyone globally has access to HashiCorp tooling. And just to highlight a few, in the top left, Zebia, they're giving a talk later today. They're here in the audience. Zebia is a very large consultancy with a strong presence in Europe as well as India. Below that is OpEx Software, who are also here today. They have a very strong presence in India. And then I want to highlight Creation Line, which is a Japanese consultancy. And so we've done this on purpose to make sure that everyone in the world can access HashiCorp tools without the necessary communication barriers of talking to us here in the States. And to make all of this possible, HashiCorp's grown quite a bit. We've gone from 2 to just about 30 people in just over a year. And I'm really, really proud of this team. They're all here today, and I can honestly say that they're the most productive team in the entire industry. What I've talked about today and what I will talk about from here on out would not have been possible with every single one of these people, without every single one of these people. So let's move on. That was HashiCorp updates. And next, I want to talk about some exciting new updates in our existing product lines. We're going to begin with Consul. As a brief recap for what Consul is, since we have so many different community members, like I said, only 1% of you fully overlap. Consul is a tool we use for service discovery, configuration, monitoring, and orchestration. As an easy example, if you have a web application and you need to find a database to talk to, Consul is the one you ask. Where's the database? Is it up? What's its configuration? What port is it on? It answers these questions. We have a major update to Consul coming this month. It's the biggest update to Consul we've ever made. And it's version 0.6. This may be less than 1.0, but like I said, Consul's already in use by many of the world's largest websites. So the first thing I want to talk about coming into Consul is something we call network tomography. And I promise you, this is something you've never seen before in a service discovery tool. It's extremely unique and unique to Consul. So what Consul does with network tomography is makes a map of all the servers in your data center. And with this map, you're able to ask it for any 2 servers in your data center what the estimated round-trip time of communication is between them. And the actual applications of this are really interesting. You could do things like, please tell me the nearest database to myself. Or you could get more complicated and say, please give me the nearest database, but if that doesn't exist, give me the nearest database in the next closest data center. You could do alerting. So you could set up monitoring that says, if a web server ever takes more than 5 milliseconds to communicate to a database, set a red flag. And you could do some really, really cool visualizations, and we're going to bring those into Atlas a little bit later this year. So most of these applications are available as really simple APIs into Consul. But what makes this really, really magical is not just the applications. It's actually the implementation of how we made this work. It's very, very interesting. So we've had this feature request since basically 0.1 of Consul, finding the nearest thing. And we took a look at prior research to figure out how you can make this happen. And we found out that it's pretty easy to do if you're working at small scale, hundreds of machines, you're working with a fairly static cluster, machines aren't coming in and out very often, or if you're okay with batching the data, if you're okay with calculating this map only once an hour. Unfortunately, each of these properties is the exact opposite of how Consul operates. Consul operates at a very large scale. Some of our largest users have over 10,000 servers in a single data center. That's just one data center. It's a very dynamic cluster. We built Consul to support servers coming in and out every second. There's no way that we could assume that the state of your data center is static. And batching just doesn't work because Consul measures the latency between machines every single second. We needed something where the map became more accurate over time as we sampled 10,000 measurements every single second. And we're able to do this in Consul 0.6 without adding a single new packet of network data. So a brief description of how this works. Let's look at these dots. Imagine that they're on a two-dimensional coordinate plane. And imagine that every node in your data center starts at the origin as 0, 0. For each measured latency, we actually apply a physics simulation to that dot, spring physics, and we push the dot. If it took longer to talk to the thing, we push it farther. If it was closer, we don't push it as hard. And over time, this stabilizes so the dots are spread out across the map based on their latency. Then when you ask Consul, where's the nearest thing to this server, it's simple math to calculate the distance between two coordinates. And we're able to do this really, really efficiently. The algorithm, if you want to look it up, is called Vivaldi. So you can see the pushing. This is a bit what it looks like, a visualization of it. And this feature is completely unique to Consul. In fact, it cannot be implemented by any other service discovery tool that's currently used in industry. And the reason for this is it requires the gossip network that underlies Consul. It's just impossible to implement other ways. And Consul is the only service discovery tool that is built on top of a highly scalable gossip network. And we're starting to see the benefits of that architecture now with features like this. The next feature I want to talk about is prepared queries. So prepared queries let you program custom logic for service discovery into Consul and expose them via DNS. So example applications of this is things such as find the nearest service, and if it doesn't exist, fall back to the next closest data center. Things such as find me the database that's tagged with primary and v2. And these are exposed via DNS, so they don't require any new changes in applications already using Consul. They can immediately benefit from them right now. There's better ACLs, so ACL coverage, access control over just about everything. So you could lock down just about everything in Consul with 0.6. And Consul 0.6 is built on Go 1.5. And this is an important thing to actually highlight because Go 1.5 made the garbage collection performance predictable. And this is really, really important for cluster stability. And we worked really, really hard to make this a zero downtime upgrade. You could upgrade from 0.5 to 0.6 across your cluster without ever experiencing downtime for even a millisecond. So to recap, the major features in Consul 0.6, network tomography, prepared queries, more powerful ACLs, being built on Go 1.5, and a zero downtime upgrade. There's many, many more things in Consul 0.6. It's absolutely huge, but you could go check those out online. And Consul 0.6 is going to be available mid-October. So it's the biggest Consul release ever. We really believe it's pushing the boundaries of service discovery. It's going to enable new applications, and we're excited to be able to do things that no one's ever done before and some things that they will never be able to do. And that was Consul. Next, I actually want to talk about Vault. Vault's the most recent member of the HashiCorp family, being just released about 6 months ago. And to recap what this does, it's a distributed, highly available secret system. So storing passwords, storing tokens to access other systems, certificates, those sorts of things. Vault stores them, secures them, and audits their access. It can lease secrets, so it could give you a secret and say, you can only have this for the next hour unless you renew it. And if you don't renew it, then we revoke the secret. It does key rolling and things like that. It's a single solution for secret management. And very similar to Consul, We have the biggest release ever for Vault, version 0.3. And 0.3 might seem like a really early release. It might seem very young. But Vault's actually already in use by really large organizations with extreme security sensitivity. Lots of financial institutions are using Vault, and sort of the hint I made earlier that if you've used money or traded stock, you've probably interacted with some HashiCorp tool. The first thing that I want to say is Vault 0.3 has been fully audited. We worked with ISEC, one of the world's leading security firms, to audit the entire Vault codebase. They raised some concerns, but we've resolved all of them for Vault 0.3. You could email us for an actual formal report of this audit. And the first feature I want to talk about is something we call SSH access control. And I think this is going to change the way that we do SSH with machines in our infrastructure. With SSH access control, instead of giving all your employees access to your servers directly, delegating usernames, passwords, it all happens through Vault. They get a Vault identity, and Vault does the SSHing for them. This increases the security by removing the need for manual key distribution, and also audits everything. We've introduced a new command, Vault SSH. This actually behaves just like the OpenSSH SSH command, so you use this instead of it. And what Vault SSH does is requests from Vault a new password. When you do this, it generates a new password for the server on the other side, logs the person in, and then revokes that password. The password only works once, and it has a lease associated with it. So if you ask for a password, you're given a password, and Vault says you have 120 seconds to use this password. If you use it 130 seconds from now, it won't work. And what's extra neat about this is because all this has to go through Vault, every single access to your machine, to your infrastructure, is audited. You know who accessed the machine, when they accessed the machine, from what machine they requested the access, and so on. Looks like that. So the next thing I want to talk about is PGP encrypted unsealed keys. One of the hardest aspects of a security system is the bootstrapping problem. How do you make a secure environment? How do you start from an insecure environment and turn it secure? That process is scary. What Vault does to bootstrap is generates these unsealed keys. And the idea of the unsealed keys is there's 5, and you need 3 to unlock the Vault at any time. It's very much like movies where you have people on the key, the red button. But one difficulty of this is with Vault 0.2 and earlier, these unsealed keys were shown, all 5 of them, in plain text when you made them. So it was theoretically possible for one operator to have the quorum necessary to do effectively anything with Vault. With Vault 0.3, each key holder can now give their PGP key to Vault, we'll encrypt it, and that makes it so only that operator could decrypt their key. It makes it so that nobody can have access to every single key. It makes the whole process secure from beginning all the way through. We're also introducing something called the cubbyhole backend. The cubbyhole backend allows people to have private namespaces for their secrets for every authenticated user. It's basically like a private file system that's secure for every single user. So when you log in to Vault, authenticate with it, and send it secrets, you can't access anybody else's secret. And this lets applications just have their own namespace to store whatever they want in any format they want, in any structure they want, and have it be secured. And then the last thing I want to talk about is something we call transit data keys. Vault 0.2 introduced something called the transit backend. And what this does is offloads encryption from applications to Vault. Vault is a tool that knows about security, knows how to manage security. And so instead of having application developers who are generally less security-minded deal with encryption and how to do that, it sends the data to Vault, says, please just secure this for me, sends it back encrypted, and to decrypt it, you send it back to Vault, and so on. The problem with this is if you need to encrypt something that's huge. If it's gigabytes, sending that all the way to Vault and all the way back is just really slow, really inefficient. So transit data keys are a more advanced feature of the transit backend. They give you the key and let you encrypt it locally using the Vault client. But then the key management is all in Vault. The decryption all happens using the key managed by Vault and so on. But it eliminates the round trip time, makes it a lot more efficient. So to recap Vault, it's fully audited for 0.3, as far as we know, very secure. It's our biggest release ever. We have SSH access control, PGP encrypted unsealed keys, the cubbyhole backend, transit data keys, and this is just on top of everything it already does. It's a full CA. It could generate SQL passwords dynamically, AWS passwords, so all sorts of other things that have already existed. And like I said, it's 0.3, but it's already in use by very security-sensitive organizations. And Vault 0.3 is available today, right now. It's already released. And so that's Vault. And that's actually all I want to talk about existing product lines today. We have Surf, Vagrant, Packer, Terraform, and Atlas. They're getting major updates over the coming months, but we'll announce them as they come, and not today. So to recap, we have Vagrant, Packer, Surf, Consul, Terraform, Vault, and Atlas. We have 7 products. We have 7 products with millions of downloads. We have 7 products that are leaders in each of their individual categories. And we have 7 products that are inspiring change throughout our industry towards a more automated future. And today, I'm very excited to make that number 8. So with great pleasure, I'd like to introduce our 8th project. It's a container scheduler, Nomad. And to talk about Nomad, I'd like to bring on stage Armon Dadgar, the co-founder and CTO of HashiCorp. Thank you.
Good morning, everybody. I'm very excited to be here at our first ever HashiConf and to be able to talk to you guys about Nomad. We are extremely proud to be able to ship Nomad today, and as Mitchell said, it's a scheduler. It's a distributed scheduler, but kind of the first question that will come to mind is, what does that actually mean? It means that effectively Nomad pools together the resources of your entire cluster, whether it's 10 machines, 100 machines, 1,000 machines, and gives you a uniform API on top of that to deploy applications. And the idea behind this is, as our infrastructures have gotten larger and as our applications have gotten more diverse, it's gotten more and more challenging to actually deploy things to this. And so now it's kind of, using a scheduler provides kind of a checkpoint, an ability for us to say, okay, is there a way for us to wrap this complexity, wrap this diversity, and build a layer that's homogeneous so that we can keep building higher level tooling and move up the abstractional chain? And so the goal is really to make it very easy to deploy our applications at any scale, basically. And to do this, we realized we needed some way that we could actually abstract the details of each of the different applications we want to be deploying. And we weren't really happy with anything that was out there today. And so when we were building Nomad, we realized we really had to build a new job specification for it. And that's what this is here. So I'm not going to spend too much time on it yet, but this is an actual runnable Nomad job file. We could give this to Nomad today, and it would schedule our Redis container. And we'll come back to this in just a second. The important part of this job file is it's declarative. It simply tells Nomad what to run. We didn't have to specify where to run it. We didn't have to specify how to run it. We just said, hey, this is a Redis job, and I want it running somewhere. And what this means is all of the details of where to actually run our applications, how to run them, what to do if they fail, how to deal with upgrades. All of these details are then left to Nomad to figure out. And the advantage of doing this is it lets us put a lot of incredibly powerful features into Nomad, but keep it very simple, because we're not exposing the complexity of rolling upgrades, of scaling, of dealing with machine failure anymore to the users. They simply express to us, this is the set of work I want running, make it happen, basically. So returning back to that job file from before, there's a lot of features packed into this that are easy to just kind of miss, because it's kind of easy to read. So starting at the very top of this, we're just defining a job. It's just a way for us to name this kind of workload, this entity. Right below that, we've specified we just want to run this job in US East 1. And really, that's hiding the fact that Nomad supports multi-data center and multi-region deployments. We could have just as easily said US East 1 and US West 1 and had our jobs span 2 data centers, or we could have put 50 data centers in there and spanned the entire world. Right below that, we see the task. A task is the unit of work in Nomad. It maps directly to our application. In this case, we've defined the Redis task that we want to run. Every one of the tasks need a way to run, a driver that specifies what we're running, and the set of resources that that job requires. So we can see in this case, we've asked Nomad to provide us 500 units of CPU, which works out to about 500 megahertz, 256 megs of RAM, and some network usage. This A allows Nomad to find a machine that has the available resources to run our job. B, it reserves that capacity to make sure we don't overcommit anything. And then finally, it lets us actually bin pack work to maximize our resource utilization and density across the entire cluster. In the middle, we're specifying how we actually want to run this job. So in this case, I've said I want to run my task using Docker, and the image to use is the latest Redis image. But drivers can actually do much more than this. In fact, the purpose of drivers is threefold. One, they know how to fetch an application onto a machine, they know how to run the application, and they know how to isolate its resources. And Docker is just one of the options that Nomad ships with. Our goal with Nomad was to support almost any workload, whether that's containerized, virtualized, or a standalone application. So if you already have existing containers and you've adopted Docker, it's incredibly easy to adopt Nomad. You simply specify the Docker driver, point it at your image, you're off to the races. But there's a lot of other workloads that require different forms of technology. One particularly good example is Vault. Almost any security-sensitive tool still to this day will benefit from hardware-level isolation. Container security is rapidly improving, but hardware isolation still offers the highest level of assurance. So with Nomad, you can still define your Vault application and ask it to run within QEMU inside of a virtual machine and run that alongside other workload in Docker on the same host. The final class of application is kind of standalone, as we call them. These are things that are already self-contained images that have everything they need to run. An example is a Java jar. Everything is already packed into a zip file. There's no external dependencies other than the JVM. Or a static binary. I could have my application and compile in all my shared libraries, and there's only a single large binary to distribute. So in these cases, we've already packaged everything that is necessary into a single atomic container, if you will, whether that's an exe or a Linux elf file or a jar file. So in those cases, Nomad will detect whether it's possible to run it directly on the host machine and isolate it using the operating system's existing mechanisms, the ones Docker is using, like C groups, like namespaces, like chi roots, and just automatically wrap that without forcing you to go and wrap it in a container or virtual machine. These set of drivers were just the ones that we're shipping with today, but there's many, many more on the roadmap. Like I said, the goal is to support a broad range of workloads. So we're looking forward to adding support for things like Jetpack on FreeBSD, Hyper-V on Windows, C#, and many, many more. And the goal is really just to highlight a few of the top-level features here. Nomad has so many more. I recommend that you go read about it afterwards. But at the highest level, our goal is to tackle application deployment with Nomad. We really want to make this extremely easy. We want to build a platform that's flexible enough for any application. And to do this, we support Docker. We support multi-region and multi-data center configurations. We have extensible drivers so that you can bring any workload you have to Nomad. We perform automatic bin packing to maximize resource utilization and density. Nothing really to do other than specify how many resources you need. And all of this is done using a really simple, high-level HCL job specification. So this job specification is really designed to make Nomad easy for our developers. But when we go and build a new product at HashiCorp, our kind of design philosophy is, can we look at what's in the marketplace and 10x what's out there? And when we went to go do this with Nomad, there was really three categories that we looked across. One was ease of use for our developers, one was operational simplicity in production, and one was building the system for scale. So it doesn't matter how big of a company you are, it should work for you. And I think we've been able to do that. The ease of use for developers really comes in two parts. One is the job file itself. It's very simple to use, it's very high level, it's extremely readable. But the problem with the job file is you need to actually run it at some point. You need to test it, you need to run validation, you want to make sure your configuration works. And so developers still need to be able to run Nomad at some point. So we've built in a special mode for this. It requires just a single flag, no configuration, and it starts a fully functioning agent. This is a server, this is a client, you can submit jobs to it and schedule in seconds. It makes it really easy and fun to actually play with Nomad. But it's not enough for it to just be easy for our developers, because ultimately this is a production-oriented tool. We have to deploy this into production. We have to be able to actually run production workloads on it. So we needed to make productionizing Nomad simple. And on this front, we've spared no effort. Firstly, Nomad ships as a single binary. both in client mode and server mode. It's just a single flag to switch its mode of operation, very similar to Consul. Secondly, it has no external dependencies. It has all of its own internal storage, all of its own internal coordination. There's no dependency on Zookeeper, Consul, no assembly required. And lastly, it's not enough just for it to be simple to productionize. It has to actually work in production. So in the design of this system, we really focused on the scalability of it to make sure even if you're a startup with 10 machines or a Fortune 5000 scaling multiple geographic region and tens of thousands of machines, that Nomad would work for you. So in building this, we started by building on our experience. And as many of you know, we make both Surf and Consul. Both of these are widely deployed in production. Both of them operate at immense scale. Surf is powering the San Diego supercomputing facility. Consul is powering Twitch, which you guys will hear about later on today. And both of them have taught us an immense amount about what it takes to build systems that are runnable and debuggable and operator-friendly at large scale. They also bring with them mature code bases that we've been able to incorporate into Nomad. But it wasn't just experience that we wanted to build on. We wanted to make sure whatever we're delivering is at the cutting edge. So we've also built on the latest research out of Google. Nomad is inspired heavily by both Google Borg and Google Omega. And we've also built on things like Berkeley Sparrow and many other research projects. For those of you who are familiar with Consul's architecture, it looks very similar to Nomad's architecture. We've been able to improve on some of the pain points that customers have brought up with us with Consul, primarily that Consul servers are required per data center. The very common feedback for us was that people want to run one set of servers to manage multiple data centers. And so for Nomad, we've introduced the concept of a region. So servers now operate at a regional level. You could say like the United States as one region, and then say US East 1, US West 1, US West 2 are each individual data centers operating within a larger region. So in this example, you can see we have the 3 clients each operating in a different data center, and the servers are shared among them. Internally, they're performing leader election, replication, and they forward requests to the leader so that it's a highly consistent, highly available system, but it's incredibly easy to use. Then, very much like Consul, we support global federation. So you can run many different regions and link them all together using the same gossip approach that Consul takes. This allows requests to be transparently forwarded to the appropriate region. So you can just make a request to any any Nomad server about any region and get the request and response without any hassle. So really, in building this system, our goal was to support an absolutely massive scale. We wanted to be able to handle thousands of regions, though why you'd have that many is beyond me, tens of thousands of clients per region, and thousands of jobs per region. So to actually test this, we partnered with our friends at DigitalOcean. And we got them to loan us some CPU cycles. So we spun up a 3 servers in their New York City 3 region, and 100 different clients in 4 different data centers, including transatlantic latencies. And we just tried to boot 1,000 containers in a single job. We jokingly call this the C1K test. Hopefully, we will be shortly talking about the C10K test with you all. And the results were pretty impressive. Nomad was able to complete the scheduling of the 1,000 containers in less than 1 second. Within a second after that, we had our first boot. In 6 seconds, 95% of the cluster had finished booting, and in 8 seconds, 99%. And so when we look at Nomad, our goals were really to 10x what was out there in terms of ease of use for our developers, in terms of the operational simplicity of productionizing the system, in terms of the scale that you could achieve and the ease of which you could get to that scale. And I think we've been able to 10x all of that. In playing with it, it really is the easiest way to deploy an application. Nomad is also available today. Its website is at nomadproject.io. There's no rush. The website will not be live until after the keynote. So feel free to enjoy the rest of the talk. And with that, I'd like to invite Mitchell back on stage.
Yep. Pretty cool, huh? We're really, really excited about Nomad. I think you saw the growth curve of Vault earlier. I think schedulers are another place that people want something that's much easier to use, much more user-friendly, and could scale. And I think we've outdone ourselves on this one. So now we have Vault, Packer, Surf, Consul, Terraform, Vagrant, Nomad, and Atlas. We now have 8 products. We're the only company in the industry with such a diverse set of products that is succeeding in every category. We've made really exciting announcements today. We've announced the 2 largest releases ever to Consul and Vault. We just announced Nomad, the easiest way to deploy applications at any scale. And really, in one day, this is the most we've ever announced. So we could probably end the keynote here, and everyone would be pretty happy. But we're going to talk about one more thing. And that thing is actually Vagrant. So let's talk about Vagrant. It is the tool that started it all, the first tool we ever had. And over the past 2-3 years, I think we've made a really amazing experience on the ops, production, and security side of things. And we wanted to look back at developers and see what have we learned over the past 3 years, and how can we make things better. So we went to Vagrant, which has been receiving updates for years, but took a much bigger look at how we can make things revolutionary. And we saw 3 things. 1, development environment deviation is pretty minimal. So what I mean by that is if you're working on, let's say, a Ruby application, and somebody else is working on another Ruby application, the things that are in your development environment are mostly similar. You need Ruby installed, you need bundler installed. It's pretty similar. There's some differences, but they're minimal. If it's a web application in general, you probably want a database. If it's a PHP application, you probably don't want Ruby. These sorts of things are just common to everything, and they're very hard to express with the Vagrant file, the current way of configuring Vagrant. They put all the burden onto the user of how to install and repeat installing all these things over multiple projects, and as the best practices change, Vagrant just doesn't keep up because it's up to the operator itself, the user itself of Vagrant, to update the Vagrant file to keep up with the changes. The second thing we noticed is that developers want to deploy. And actually, we didn't just notice this. This has been a feature request in Vagrant for about 5 years. Everybody wants to Vagrant up to production. We showed how easy it could be to Vagrant up to development, and they want that experience, but with production. And we've had trouble making this work in Vagrant. And what we realized was a Vagrant file just isn't the right level of abstraction to describe how to deploy something to production the way you actually would want to. A Vagrant file describes how to set everything up onto a single machine. It describes how to install things for development, debugging tools, how to configure things in an unsafe way just because you're developing. And it's hard to describe without repeating everything how to go into production from there. So the Vagrant file just isn't the right approach to doing deployment. And the last thing is microservices. An undeniable trend over the past 12 months, at least, it's grown very quickly. And microservices are something we embrace very heavily at HashiCorp. It's something that all our tools are designed around to support the scale of microservices. Microservices make it from going from one application to effectively hundreds or thousands, and this has been hard for Vagrant to keep up with. Again, the Vagrant file makes it difficult to develop microservices because you have to manually configure how to install every dependency and keep up with all those dependencies over time, which might be being worked on by multiple teams. So as one team changes the way you install something, it could break a bunch of downstream development environments. And it really just puts a big burden on the Vagrant file maintainer. And this really isn't unique to Vagrant. I think overall everyone would agree that with microservices, despite all their benefits, are very hard to develop and very hard to deploy, at least orchestrating those aspects of it. And multi-VM, which Vagrant has had for 5 years, just isn't the right fit for microservices. Multi-VM was made for a couple big different environments, and really even a modern laptop can't run more than a half dozen or so VMs. So multi-VM was not the right approach for microservices, and it wasn't designed for microservices in the first place. So that is what we learned in the past many years of Vagrant. And we realized we could do a lot better than this. We've built the tools that enable us to do a lot better than this. And we've solved it, but I think in a way you might not expect. We built something else. Its name is Otto, and Otto is the successor to Vagrant. Otto's three things. Otto is a revolutionary new development tool, a revolutionary new deployment tool, and a revolutionary tool for working with microservices. And to make all this possible, we've created a new format for configuring Otto. We call it the app file. And the app file is the simplest configuration format we've ever made. You're really going to love this. So let's show the app file. Here it is. Yep, it's not a mistake. The app file is completely optional. If you clone out any project, run Otto in it, Otto will detect for you what kind of application that is. It'll notice it's Ruby, it'll notice it's PHP, it'll notice it's Node, and it'll apply the best practices it knows of at the time to develop and to deploy. So let's show a complicated app file. How complicated can this thing get? It is a real format. Here's a very complicated app file. It's beautiful. You tell it the application name, you tell it the type, you give it some dependencies, and maybe you customize some things. Again, this is all optional. The blank app file is real. You don't need an app file. But if you want to, you could create it. And notice that we don't describe things like what operating system to run, how much memory you need, how much disk space you want, things like that. Otto has built-in knowledge of what the current best practices are to make this work for you. If you want to specify them, you can, and that's what customizations are for down here below. You can see we're customizing the Ruby version in this development environment. But you don't have to do that. And you can even see the customizations are still pretty high level. You're not telling Otto how to install the other Ruby version. It knows how to do that, so just tell it the version to install. If you did want to specify custom commands, you could go farther, but we think we've gone at a level high enough that it gives you 99% of what you need. And this is the beauty behind Otto. It's a key design architectural difference of Vagrant. It's the idea of codification versus fossilization. If you take a Vagrant file that was written 5 years ago and you ran Vagrant up today, it would still work. But what Vagrant would do is bring up exactly how you configured that environment 5 years ago. And that is one of the benefits of Vagrant. But for application development, for application deployment, it's not always actually what you want. What Otto does instead is codification. What Vagrant does, we call fossilization. It makes it a fossil. It imprints it, it snapshots it, and it doesn't change for all of history. Codification is the idea that we have something high level enough where the knowledge is centralized in Otto instead of the configuration file. We have this centralization of knowledge of everybody, of the community. As Otto grows, Otto will learn more. So if you take an app file today and run Otto 5 years from now, it won't bring it up the same way. It won't deploy it the same way. But it's going to deploy it in a way that's correct for 5 years from now. But if you run it today, it'll set it up for today. To say this in a concise way, Otto's very smart, but Otto will get smarter over time. As the community grows, as more people use Otto, that knowledge will be encoded into Otto itself, and the next time you run Otto, things will just get better. So let's look at what the development experience is like with Otto. We have a lot to live up to with the simplicity that Vagrant brought. Vagrant's Vagrant up command is almost iconic these days in its simplicity. And of course, we've done something very similar with Otto. Otto dev is the only command you need to spin up a development environment in Otto, and it does everything you would expect. Here's the example of the output that you would see from Otto. It creates a development environment. It installs Ruby. As if you're developing a Ruby application, it would install Ruby, install bundler, things like that. Sets up networking so you could access it without any configuration. And then at the end, it actually gives you a human-readable description. This is built into Otto of how you could then work with that project. And this is great for developers who might be working on something they're not familiar with. If you have a Ruby developer and you suddenly throw them on a Node project for something very simple, they could run Otto dev, and it'll give them human-readable output to describe how you work with that project. Things that you're used to are still there. We have Otto dev SSH. It's still at the Vagrant directory, but it's Otto. The difference between Otto dev SSH and Vagrant SSH, for all of you who are familiar with Vagrant, is this command takes about 100 milliseconds versus a few seconds. There's a way to ask for the address of the machine. This will allow you to easily access your development environments. And then, of course, very similarly, when you're done, you can destroy everything as well. And this output's going to look very similar to Vagrant because we are using parts of Vagrant where it makes sense. We didn't want to rewrite 6 years of code wisdom. And ultimately, what we've created is a really wonderfully simple development experience. It's easier to get started than with Vagrant. It requires 0 configuration, 1 command, and sets up everything for you that you would need to get started with that project. So that's development. It's really, really that simple. And now let's talk about deployment. So once you're done developing, the obvious next step, the next step people have been asking us for 5 years, is to be able to deploy. So what does a developer do today? An average developer. Let's say you Google how to deploy an application, and let's say you Google how to deploy a Ruby on Rails application, since we've been talking about Ruby, but it could be anything. This is what you end up seeing. We just Googled this yesterday, so this is on point. And these are the real results we saw. And these results aren't disheartening. If you were a developer Googling this, the first one actually ends up being useless, but the second one looks exactly like what you would want. How to deploy a Rails application with Apache or Apache on ... And you read the description, and I would look at that and get excited if I was Googling this and be like, that's exactly what I want. This is perfect. So you click that, and you look at it, and you see something like this. It's just copying and pasting a bunch of random code into a terminal. And this wasn't a best practice 15 years ago, so why is it still a top hit today? Well, what would you really want to do? What you would really want is to be able to have today's best practices to deploy an application. And today's best practices for a basic application look kind of like this. You kind of want a private subnet, a private network that you can't access from the internet to put things that don't need to be accessed from the internet so they can be more secure. Things such as your web servers, your databases, and all your microservices over there. These don't need to talk to the internet, they just live on their own. Then you want something like a public network that the internet does access, that people do access. Things like load balancers, so your website could get served. Things like a bastion host that give you access to that private network for people that are authenticated. And things like NAT, so that all the private things can talk outwards to the internet, even if things can't come back in. And this is complex. This is very difficult. Very few people actually know how to set all this up, and the people that do, I think, will agree that there's a lot of domain knowledge necessary to do this properly. So we've actually built tools to make this easier. We have tools like Terraform. We have tools like Packer, Consul, Vault, and Nomad. We have tools to make this easier, but think about it. We have 7 other tools to make this easier. We've made things easier individually, but as a whole, you would have to learn 7 new tools to make this possible. And that's an incredible learning curve to tell somebody. And that's why this is still the top result on Google. This is still easier than everything that we've built in the past 3 years, until today. With Otto, we have a 3-step deploy. Otto completely manages your infrastructure, completely manages the application build process, and completely manages the deployment of those applications to production, or any other environment for that matter. Infrastructure management will build you that best practices thing that I showed you earlier. You'll get a private subnet, you'll get a public subnet. There's other flavors of infrastructure you could request from Otto to make things a little bit simpler if you don't want to spend some extra money on servers. But Otto can build you a best practice infrastructure that could scale from a hobby application up to thousands of servers. The build process will turn your application from source code into things like an AMI or a container, something that Nomad can run. It turns it into the thing that's ready to be deployed. And then finally, the deploy command actually sends it out to servers and gets it running. And if you run the Getting Started guide through Otto, we'll show you how to do this with 0 configuration, no app file, get a Ruby application from nothing to development to fully deployed and accessible by the internet in just a few short steps. And things like infrastructure are shared by multiple applications. So you could deploy multiple applications on the same infrastructure. It's part of why it's a separate command. So you only need to build that out once, and it could be a shared resource. And that is deployment. It's very, very easy. And next, I want to talk about microservices, the last sort of thing we recognize about Vagrant. Microservices are the trend that are replacing the idea of monoliths. Monoliths are the idea of putting everything your application needs into that application. So all the auth, all the features, everything is just in one big application. The weaknesses of this, of course, is that if someone breaks one thing, the whole thing goes down. It's very big to deploy. There's a lot of people working on one thing. It's very complex. So the idea of microservices grew, which is to break that down into a few, a dozen, and hundreds of little single-purpose applications that communicate with each other. So there's only one thing that's responsible for logging people in. There's only one thing responsible for showing them their news feed, that sort of thing. And this is microservices. And at HashiCorp, we think that this is really the future. This is the way things are going to move towards. They already are moving towards this right now. But there's some challenges with it. Microservices bring new challenges we didn't have before. Mainly the challenges both development and deployment. In development, instead of having the one application that has everything you need, you now have the one application that needs to talk to another dozen applications, which need to talk to another few applications to make things happen. So for you to work on one thing, you now have to know how to install potentially dozens of other things into that application. And that's pretty complicated and also just puts a huge burden onto the end user to get it right. And if the microservices change upstream, then you could be in a lot of trouble. For deployment, they're much the same solutions. You need to deploy everything. You need to make sure you're running. You now need to find them over the network. You need to make sure they're monitored, things like that. So this is all very complicated and not unique to Vagrant or anything. This is a general, difficult trend in the industry right now. Otto makes developing and deploying microservices very, very easy. So let's take a look back at the complicated app file from earlier. So you can notice in the middle here, we have something that says a dependency. You could have many of these things. We only have one here. And it has a source URL that points to, if you look at the end, Postgres. And the source URL is a URL. So it could point to things like GitHub. It could point to things like HTTP addresses, file system, anything. And the idea is you point to what you depend on, and it defines how it's installed, how it's configured, and so on. The burden of how to install and configure microservices or anything you depend on is up to the team that's making that thing. As a user, you just say that you depend on it. You also only need to specify your immediate dependencies. If we depended on a service that then depended on 3 more, we don't need to know that. We just say we depend on that one service. It says it needs to depend on three more. Otto automatically fetches the whole set of dependencies, and since they each define how to be installed, it all happens automatically. So if we run auto dev like we did before, it looks pretty much the same, except you'll start seeing output such as installing dependency, configuring dependency. So what auto dev here does is still creates a single virtual machine, but installs everything and starts it and configures it into that thing. And then it makes it available via Consul automatically. You don't need to know how to install Consul. You don't need to know how to set it up. It's all there. So if you log in and look it up, you could actually see where that thing is, access it, communicate with it. And as the end application developer, you don't have to worry about getting that thing running. It's going to be running, and the idea is it should be running with mock data already in it. It should be running automatically configured for development, and should be easy to get going. Then when you deploy, it's not all that exciting because it's pretty easy. It deploys it, gives you the address, but Auto makes sure that all the dependencies are deployed. It deploys them if they're not, and it makes sure that only a single instance of that dependency exists, and a future version will let you deploy duplicates if you want. It's really that easy to work with microservices. We think we've solved a huge problem with development and deployment of microservices and removed a huge barrier to do it. So to recap, Otto is a revolutionary development tool, a revolutionary deployment tool, and a revolutionary tool to work with microservices. And we've done this all with the simplest configuration format we've ever made, which is the app file. We previewed Otto to Condé Nast, which I talked about earlier, and they were nice enough to say this. They said, the industry has needed this kind of abstraction for a long time, and it's finally here with Otto. They're excited to get started with it. We're excited to show it to everyone now. And Otto is available today as well. It'll be available at autoproject.io, and like Nomad, you won't be able to visit that till shortly after the keynote, so don't worry about it. And that's Otto. We're super, super excited about Otto. I think it's really the first tool of its kind. It's sort of a new category, but it builds on top of everything we've built over the past few years in order to solve some major new problems. So now we have 9 things. We have 9 products. We announced 2 of them here today. We announced 2 major updates today, and we think we have really the best portfolio of software in the industry. And that's all I have for you today. So thank you very much, and have a great, great time at HashiConf.
Awesome. 2 new products, both available today, and 2 existing products with huge updates. We're super excited. We have a short break now. I want to thank all of you for coming. I thoroughly hope you enjoyed everything we have to share with you today. All of our engineering team is here in Portland, and they'll be at the HashiCorp booth through various stages today. So if you have any questions about Nomad, Otto, Consul, Vault, Atlas, please feel free to ask. You can ask anyone in a blue HashiConf shirt. We have about a 30-minute break, so please feel free to exit the theater, talk amongst yourselves, hang out on Twitter. Up next in this room, we have using Vagrant, Docker, and Terraform to streamline your development and demo environments. And in the by LN stage, the lower stage, so if you go down the stairs behind registration, we have Operating Console as an early adopter. So you'll notice there's this common theme that blue is the main stage and green is the lower stage. Outside, you'll see the same schedule is posted on the main TV monitors outside of the door, and they're also posted downstairs in the by Ellen studio. This concludes everything we have for this morning's keynote. Thank you so much for coming, and we look forward to speaking with you